right here.
Oh. Everybody should be reading the question because you could be at D. High altitudes are above the atmosphere. Does it necessarily have to be above the atmosphere in order to be a high altitude? Yes, no? No? Who was watching the video? You staying good? Huh?
We can rewatch the video.
I'm getting ready to give y'all this grade.
B. It's B. Please stop. The atmosphere is clear, the higher you get up in the
Alright, so she said the atmosphere is thinner. What y'all say? Huh?
Yeah. I said
More carbon dioxide?
wait, we in our groups.
Yeah, I said yeah.
Alright, which quote supports the idea that the atmosphere keeps Earth warm enough to be a perfect habitat for plants and animals? Which quote supports the idea that the atmosphere keeps Earth warm enough to be a perfect habitat for plants and animals? Huh? Nairobi.
I think it's C.
Okay, she said C. Very good. All right. Alicia, which term accurately describes the exosphere? The exosphere. Which term accurately describes the exosphere? What you got? You can close the door. What you got? Let's see. Ashaya. You saying what? A? The exosphere is unstable. Anybody else? Huh? Oh, if you think it's A, don't you don't have to. You think it's D? She said dense. Who else says? Who says A? Who says D? That's pretty much like a tie. Let's see. Unstable. The exosphere. Where's the exosphere?
It's the top base. Top base. The highest one. It's basically it's in space.
Right. They did talk about the ionosphere, but we went as far as the exosphere, right? So if we're at the troposphere, the exosphere was the 5th layer. Check it or hold it. Check that up.
Sure.
All right. Nyla, what does the root thermal mean in the word thermosphere? The root word thermo, what does it mean in the word thermosphere?
Is it
Meteors?
I think it's B.
Heat.
When I think about thermal, I feel like it means kind of like temperature.
Okay.
Sort of temperature.
So you think of temperature when you think of thermal? Or what about these Stanley cups y'all carry around? Does that not keep your the temperature of your drink?
Right, it keeps it cold.
So if you had a hot drink in there, what would happen?
It would stay hot.
It will stay hotter longer.
Yeah, because it don't have any ice in it.
Right. But it's insulated, so it's going to continue to keep the heat. Yes. Go ahead. All right. Y'all saying heat? Very good. Kaylin. All right. Match each layer with its description. Kaylin, she's gonna do the first one. Each layer with its description. Protects from meteors. Which layer protects from meteors? The third one, mesosphere. All right, she says it's the mesosphere. All right. As a matter of fact, is Autumn here? No. All right, let's see. Taylor, come on up. Taylor, I want you to do, you do exosphere. Find which one you need right here. Cameron, you're gonna do thermosphere. Take it and drag it. Click over there and take it and drag it. Hold on, one at a time. Yetili. Is she in here? All right. Jacayla here. Stratosphere. Serenity Bradley. Exosphere. So are these correct?
Yes.
All right, so when you think, this is basically like saying, oh, I want that.
Oh, alright.
Finger. Finger. Not your whole hand, your finger. All right. What you think? Y'all did good?
Yeah.
All right. So what you're saying to me is that this is kind of what you want to have in your mind if you were doing a definition of these. Okay? So mesosphere, what is it? You say mesosphere does what?
Protects from meteors.
Protects from meteors?
Yes.
So what happens when the meteors come into the mesosphere?
It burns them.
Close them up. Okay. Exosphere. It has what? You all need to be paying attention. London. All right, ladies, y'all get up or stand up. Sit up or stand up. All right, so which one is closest to the Earth? Which one contains the ozone layer? And the hottest temperatures are located where? All right, so you probably can put this together, right?
Yes.
All right. Good job. All right, place the layers in order from highest to lowest altitude. So basically, you're gonna have to click and drag. The lowest altitude, what would that be?
The troposphere.
All right. Let's see. Kayla, Holland. Place the layers in order from highest to lowest. Okay, so we're gonna start with highest. All right, Kayla, you're gonna do highest, and click and drag. Then, Kayla, come on, you're gonna do whatever comes next. All right, she said the thinnest layer is the highest. Which one's next? All right, what else is next? So far you have the thinnest layer. You're saying the thinnest layer is the highest. Come on, it's the same thing as what was on the previous slide. Oh, London. Let's go. Then we have Sierra. You'll do one after London. So far we have this, that the thinnest layer is the highest. Then we have the ionosphere. What is next? Now, if you see something that needs to be corrected, correct it first. Come on. Come on. Yes. I'm going through the cut first.
Oh,
Charisma. She's not here. All right. All right, then I'm going to go back to Anessa, Nairobi, and Alicia. Who did I not call?
You called me one time, that's all.
Come on up. Okay, come on. Weather layer. The weather layer is in the middle. You can take off the one you just put on. Drag it. I'm sorry, hold on. You want the weather layer to be the second highest? Where are you? Does the weather affect you? So if it, ladies, just drag it. Okay. All right. I need y'all to pay attention because a number of you who are doing stuff on your computer, because that comes after this. Okay. I'm going to take the computers in just a moment. Bring me that computer. You won't get that first.
fine, I'm so sorry.
No need to apologize. It should be back there. Put it where it goes. All right. What's next? Come on up. Did you come up? Did you come up? Come on. Come on.
Can I check something or you want me to do the last one?
Go ahead. Go. You check whatever you check.
I feel like the thinnest layer is not supposed to be on the highest.
Okay.
I feel like, cause I was playing picking to the last one, I feel like.
All right. Where you gonna put that one? You understand? The mere fact that we don't have it on our charts tells you.
The mere fact.
Yeah, the fact that we don't have it on our chart, yes. What layer is this?
The thinnest
Okay, well, what layer? What's it called?
layer,
What's the thinnest layer called?
the
the highest. This means up here. Like if you're doing your drawing, huh? No, you're right. All right. What layer should be here?
In ionosphere.
Very good. Because and then I thought
Because it's above the X.
it is. It's above the exosphere. The mere fact that we are not doing the ionosphere should tell you that it's past the exosphere. Correct?
And then because it doesn't affect us.
That does affect us.
Oh, it does.
Do you not see the weather?
Yeah,
So
but
Hold on.
She said it doesn't affect us.
It
Hold on.
usually comes from like higher above the
Should be right.
in the troposphere.
Say it. Don't touch it. So what layer is it? Tell me the name of this layer, the lowest layer. The troposphere. Where is the weather at?
In the troposphere.
In the troposphere, because who else is in the troposphere? Exactly. So do you see the clouds?
Yes.
Do you see the rain?
Yes.
So why would the weather not be in
it's
your
the weather.
layer?
Right.
Correct?
Yes.
All right. So the troposphere is the weather layer. What's next?
Ozone layer.
Ozone layer.
Because it's in the stratosphere.
The stratosphere?
And the stratosphere is after the troposphere.
Where does the ozone layer come? Because the ozone layer is right here.
It's in between the stratosphere and the troposphere.
The stratosphere and the troposphere? Oh, okay. So you're saying that this goes right here?
Yes.
Correct?
Yes.
Okay. Then so you have the, what layer is this? Troposphere, and then this is the ozone layer, and then this is what? And it's the what?
Oh.
What comes after the ozone layer? You know what comes after the layer. Okay, so that means that the stratosphere would be which layer? Put it there. Then what's the thinnest layer? The thermos. So you would have like the thermosphere would be here, and then what would this? Well, they took usually when they say ionosphere, they talk about ionosphere just like they would talk about the exosphere. Okay. So with these, you already knew everything here. You already knew all of these things here, except for we really didn't focus much on ionosphere, but it did tell you in the video. So that tells you when the video is playing that you need to be paying attention to it. All right, so they are saying, take that over that way.
No, you gotta click on it and
And I bring that back up. So, I mean, yeah, the thinnest layer would be whichever's furthest away. I'm gonna check on this because I don't know. I want to say that still said it was wrong, but let me check on that, okay? It was. All right. So, how does the ozone layer protect life on Earth? Nairobi.
It absorbs the radiation from the sun.
All right. All right. Let's see what that was that we were looking at. That was 6 that we were looking at.
Mm-hmm.
Weather, ozone, coldest. Oh, they want to say coldest is here. Cold. Yeah, we did coldest right here, right?
Mm-hmm.
Then we switched these around, didn't we?
Mm-hmm.
So I wonder why it was still wrong. Okay, so apparently you got that. Yeah, it's something. I don't know why they did that, but you got that right. All right. All right. So now you can do your group work. I think you all pretty much got everything right on that then, right?
Mm-hmm.
All right. So now it's time for you to go ahead and do your group work. It is 11:20. You are going to have
You pass my computer. Okay, you got it.
Don't excuse yourself. You wait until I turn around and answer you. Alright, you are going to gather data
Okay, we need
on your assigned layer of the atmosphere.
Cameron is the alright. I said we can do a camera and like make a
Ladies, you are going to gather data on your assigned layer of the atmosphere. You are going to work in your group. You are not in a group of you are sitting apart from your classmates. You don't necessarily need to decide, you just need the information. So you're going to need to have, you're going to take your layer, ladies, you're going to take your layer and compare it to the other layer. You got it?
Yes.
Checking and holding, ladies. Take your layer and do what?
Compare it to the other layers.
All right, compare it to the other layers. And then you're also going to include what?
Information.
You need information on
Your
what?
Your assigned.
You're going to need information on the ozone layer as well. And what else? And what else? Greenhouse gases. Good job. All right. You'll need a visual. So that means that you're going to have some type of a picture. You're going to have 20 minutes.
I'll look up the picture.
Your 20 minutes starts now? Yes.
We're gonna make a slide like this.
Her computer back so she can help us try it. Can Taylor get her computer back?
Taylor needs to answer her computer. Are you her spokesperson or something?
It's literally okay.
An example of the okay, what picture y'all want to do like this? Would y'all want to do it like this? Something like this. Besides all this,
Can I get my computer back?
all of our information.
Yeah.
Okay.
All right, make sure everyone knows what they're supposed to be doing in the group. Everybody should be attached to the actual assignment. That way, everybody has something that they can do. Gather the information first. You don't need a design on anything until you gather the information. That's a lot of information.
Okay, so
Gather your information first.
okay, so
Use your time wisely.
Okay, so then so we're gathering information. So we're gathering information
Or you could just do the same document.
And then y'all come. Share all of it. And like, I'll put it together. Let's put this together.
Y'all understand? Okay, no problem. Do we have a document created? Will be on the same time? Created a document. Okay, so you're gonna add her to the document? You gotta go with share with me. What you got it on the doc? You got it on the screen? You got it on the doc or slides or what? And then you gotta share it with me. Did you open it up? Did they share with you? Whose strength bottle is this right here? I spit it clear.
But yeah, so I just take that shit and then it leaves and I just use it.
So who put all the stars?
Okay, and then we gotta look at the information.
You can leave that like that. Okay, so you remember last time, right? You don't go in there and take it. So you did that last time. Alright. You did another time. You take it out or erase it. Okay, so who's doing the research? Okay, everybody's doing research. Listen, ladies, don't forget what I just said, okay? The research happens first because no one creates the whatever you might be doing on Canva and then all of a sudden there's no information to put on it. You got it? Everybody needs to be doing some type of research.
Wait, so we have to do it on Google now?
You do it on what you want to do it on. Bring that back in because you just took all of them out of the frame. And I already asked you to stop erasing the things that she put on there. You erase one more thing somebody took out, you're get your grade right now.
The document will be shared.
Y'all working together. That's enough with the stars. That's enough. All you have to do is hit the back button. So you start with stars. Fix your stars. You have to compare your layer of the atmosphere to the others. That's a lot. Get your work done. Have you decided who's going to do what? You have about 11 minutes, less than 12 minutes.
What side do we compare the measures to the other one?
Okay, so you want to put this
First of all, you want to gather information, you want to gather data on your particular atmosphere, okay?
put it in our own.
Oh, that's what I know. Oh,
No, you gotta put all the layers.
to the other layers, not to earth. That's way too much. You gotta put a I'm sorry. Like, I got the information, so I'm trying to write it. No,
Do you have ladies?
We're first, we're talking about like all the layers of the atmosphere.
wait, that's
They
too
know
much.
layers first, so that's what we're talking about right now. And then,
So y'all want to do some, y'all want to split up a little bit, okay?
okay.
So if your layer, so you want, the head of your document needs to be whatever your layer is, not the layers of the atmosphere.
Oh, okay. We can still talk about all the outside layers.
Because you're comparing them.
Right.
You're comparing them, okay? So you have, you're gonna obtain and evaluate data. You gotta get the data for your layer of the atmosphere first.
Okay, so
Once you do that,
then we can compare it.
yes, okay, you gather some information from the other ones, but you're gonna make sure you put that in, that in your calendar. Okay?
Okay, thank you.
You're welcome. How you doing? How we doing?
Just keep doing.
Alright, so we use that information. Okay, then we use BG.
So the very first thing you should have looked up was the, your layer of the atmosphere. Gather your data for your layer of the atmosphere. You remember when you did the pictures, when you did your 1D model, you talked about, well, you drew different things that were in your layers, that could exist in your layers as it's passing through. You also need to be talking about how large your layer is, what the temp is, things like that. Give us some information about your layer. Not necessarily fun facts. Fun facts is research. So you create your research. 8 minutes.
I think we need to type first. Wait, that's we have some after the one thing is right now. That's Okay, so no. We have to compare this to all the other stuff.
You got Google, you go right
I
on.
know, and I already have what I can write. Say me right. I can't write it. Oh my God.
Alright,
Which I was sure.
Did you share with me?
I placed it over our head. Layers. Okay, is this the other one?
We gotta work on it for work.
We have to compare. It is compared. So here's why the surface fit. That's not what they mean by compare. They mean like compare the sphere to the other atmosphere. That's not comparing. Oh, hey, what? I heard that. What is no, that's not.
So you just take a picture of it. And then take it. Be like, God. Now, let them just do it.
We have 5 minutes and 40 seconds. All right, listen up. As we count down to our 5 minutes, I'm gonna come and see where you are as far as your presentation that you have to put together. You will be working on this for homework, checking or holding. Finish the discovery of your layer of the atmosphere presented on Wednesday. The biggest part is your layer of the atmosphere. That needs to be the title of your actual presentation. Put that up because it's keeping you from typing. All right, and then you want to have a few things that make it different or special from the other layers, okay? You don't need a whole bunch of information about the other layers, just a few things that make it different from that particular layer, okay? But your discovery is basically the layer that you are assigned to. And give us some information about greenhouse gases in the ozone layer. You just need to know about those. And if it affects the layer that you happen to be investigating, then you include some of that, okay?
That's too much.
I got the same number. We're done with them.
I have that. But we're doing that.
Like,
It's called science. It's blue and green. It's called science.
Oh, water on my ears.
you have less than 4 minutes.
Where do we submit it?
Okay.
No capital.
No, she just said.
Hold on to it. I don't have. If you're done, one person can share it with me. If you are done, you have the same document. You can. If you are done, make sure that you
We're comparing the atmosphere that we're doing to all the other atmospheres, right?
Yeah, but you're only getting a little information on the other atmospheres that make it not yours. Okay?
I shared it.
That's what we probably can.
I changed the colors. It's not easy. Yeah, just figure it out. But we don't need all of that information.
Okay.
We still have more sites.
Okay, cool. Oh, did you get?
However, you should comparing the other atmospheres.
Okay, now, we have a little bit more. That's some information, that's troposphere. I don't want it copy and pasted. I want it to be something, ladies, do not copy and paste a whole bunch of stuff. You need to be writing something that you could probably say without looking at it. Just like your vocabulary, when you do your vocabulary. different slides, and everybody can work on a different slide.
Okay.
I don't think the last one. What? That's not the last one. Also, I talked about this. I know that's not the last slide. That's not a good last slide. We still have more to do. We have more to do. Yeah. And do you want to work on this?
Okay, so we have a beginning cover and ending cover. I want to say
Oh, so that one means we don't have to do it. So first,
Okay, we need to spread that out.
just let me keep it how I heard it. It was. Ooh, the first one you put like 20 paragraphs on there. She just said a whole lot of information.
We have I do all
For everything, you don't need all of the information. And with this apparently, we don't need like 20,000 paragraphs and explaining to them, you know? Yeah, well, yeah, I have sugar.
And then I did number 5. Then chemical, so I did all my reading the the discovery of it. Make sure you all create whatever you're using. Or make sure you got Canva.
No, so number 4, what I would do is
Whatever you want to do, you create that.
I have information. So you can use that.
You gotta do a presentation. 27, you have less than 30 seconds. If I leave, I feel like
The mesosphere, we're comparing it to the other atmosphere. We don't need this information. That's not comparing it to the other atmosphere.
Exos.
This slide clearly says as compare. If we're comparing it, don't you know? Like,
All right. Here we go. All right, everybody. 1, 2, 3. All eyes on me. All right. Did you save your document? If it's a Google Doc, if it is a Canva presentation, you need to make sure you have it together. But you're gonna, whatever it is, you're gonna send it to me, and it's gonna be up on the screen. So if you're just doing a document, you have to have a presentation. So feel free to do your document to gather your data. However, you need to have some type of presentation, okay? That's what we talked about first. Check the holder. All right, finish it for work. Homework. Make sure you and your group have access to it, so you can work on it at different times or together. All right, we are going to highlight your findings. Give me 10 seconds. What did y'all find? What'd you find? 10 seconds.
we found out that the ozone layer contains too much ultraviolet radiation from the sun, and also the stratosphere is considered one of the coldest layers. The coldest layers of the atmosphere.
Okay, there you go. All right, that group, go.
We found that
Quickly.
the troposphere contains Earth's water and the greenhouse gases to maintain the temperature on Earth.
All right, good job. Back in the back, y'all ready? Go. Go ahead.
The mesosphere lies between the thermosphere and the stratosphere. Meso means middle and the layer of the atmosphere in which the gases are all mixed up rather than layers by difference.
All right, got it. A little bit longer than 10 seconds, but that's fine. It's a quick sum, yeah. In the back, ready? Y'all ready? Go.
The thermosphere, the thermosphere is the layer in the Earth that is directly above the mesosphere and below the.
Okay. Give me 1 second.
The exosphere is important because it acts as the first layer to absorb solar radiation before it reaches Earth's surface.
Sounds good. How's that? Y'all almost there then, right? All right, you got good stuff? So when you get ready to do your presentation, you're gonna start at the troposphere and you're gonna go out into the Earth, the galaxy. Checking and holding?
Check.
So you already know who's first. Who's troposphere? That means you're first. All right. All right. Here we go. So conduction, convection, and radiation. That is when you talk about conduction, convection, and radiation, you're talking about heat transfer. All Chromebooks you can put under your desk. I do have the pause points on. So when you talk about heat transfer, it's going to transfer in many ways. You are welcome to take notes if you like. London, come on up front. Ladies, can you bring that desk back over that way, Karen? Get your stuff. Anybody else need to move up? Bring that desk over. And that other desk. You can sit right there. All right. Remember who you are in your group with. Did you all put your name on your docs? Okay, good. All right, here we go. Make sure you're paying attention. Let me turn this music down. And let's go with heat transfer. This looks like people's court, doesn't it? You going into the people's court?
Published author. He purchased a half-cap caramel macchiato at a local coffee shop. After writing about the rich history of the rubber band for just a few hours, his drink was ice cold.
All right. Why do you think Moby's drink became cold?
Because he let it sit there.
Can't hear you.
He let it sit out for hours.
Did I not say put the computers up?
Oh, no.
He let it sit out for hours. Anybody else? Huh? Anybody agree, disagree? All right.
The cafe wouldn't refund his money, and now he's suing. This is Tim,
Now
the
sit up.
cafe's barista. He says the customer is always wrong. Plus some know-it-all stuff about physics and molecules. What you are about to witness is real. The participants are not actors, they are actual litigants. Both parties have agreed to have their case settled here, before Judge Marilyn Mainframe, in our forum, the People's Court.
Your Honor, I'd like to admit this letter into evidence, just as soon as I read it. Dear Tim and Moby, how does a thermos keep my suit from getting cold? Thanks, Mrs. Nichols' class. Now, Your Honor, Mrs. Nichols' class brings up an interesting point, because, as we've all noticed, hot things don't stay hot. Once soup or cocoa or single origin fair trade coffee comes off the stove, it starts to get colder. And it'll keep cooling off until it's the same temperature as the room. Cold drinks do the opposite. They'll keep warming up until they reach the temperature of their surroundings. Yes, putting a cold drink in a thermos will slow the warming, or the cooling if we're talking about a hot drink. So, the plaintiff's foofy espresso drink would stay hot longer, but not forever. Wait long enough, and that macchiato will be room temperature. Thermoses work because they minimize heat transfer. Heat always flows from warmer objects to cooler ones.
Warmer to cooler.
And the greater the difference in temperature, the faster it'll happen.
Alright, so what would happen if a hot cup of coffee was moved from a warm place to a cool place?
It would get cold again.
Come say it together. Which one?
A.
The only way to keep some coffee from cooling is to put it somewhere just as hot. Is the plaintiff suggesting I keep my establishment to 140 degrees? Because I really must point out, 140 is the only proper temperature for a macchiato. Sorry, Your Honor. I get a little carried away. Now, we've established that heat's always on the move, from warmer to cooler objects, and that a thermos can slow this process down. But to understand why, we need to get closer, a lot closer. Coffee, like any other substance, is made of tiny particles called molecules.
A molecule is the smallest bit of a substance like coffee. Coffee has different kinds of molecules, including water molecules.
And they're constantly jiggling and bumping into each other. In other words, they have kinetic energy, the energy of motion.
What is an example of kinetic energy? The type of molecules in coffee or the movement of molecules in coffee?
Of course, we can't see any of this microscopic action, but we can feel it in the form of temperature. That's the average kinetic energy of all the molecules in an object. The warmer something feels, the faster its molecules are moving. I'm getting to the point, Your Honor, I promise. Because all of this microscopic motion is what makes heat transfer happen. First, through conduction, the transfer of kinetic energy by direct contact.
Alright, so conduction. If you've already written it down, that would be great. Conduction, the transfer of kinetic energy by direct contact. Conduction. I'm gonna add that to your term. And I'm going to add it onto the weather, the one with the weather, okay? So I want you, you're gonna definitely do heat transfer.
Ms. Huff,
No, I'm announcing his name on the button. Alright, conduction, transfer of kinetic energy by direct contact.
When you hold a cup of coffee, your hands get warm.
Kinetic means
That's
it's
because
movement.
molecules in the hot cup are slamming into molecules in your cooler hands.
I don't have no.
This is conduction.
Mine's inside.
With each collision, the faster molecule slows down and the slower one speeds up. Multiply that by a bazillion molecules and you can guess what happens. Your hands and the air all around the cup absorb energy from the hot coffee, sucking away its molecular speed, which we read as a drop.
What does the growing red circle represent?
A.
Heat leaving the coffee?
Yes.
Yes.
Good job.
Temperature. But what if there weren't so many molecules around to bump into? That's one way thermoses minimize heat transfer. There's basically a bottle inside another bottle with empty space in between. It's a vacuum, a space with no molecules in it. So there's nothing there for the molecules in that hot bottle to bump into. Heat loss through conduction happens only at the very top of the bottle, where it's attached to the outer container. Well, there is one type of heat transfer that can go through a vacuum. It's called radiation. It also comes from the movement of particles, but on an even smaller scale. Molecules are made up of atoms, which you've probably seen drawn like this. Those little dots orbiting the center are electrons. When atoms are energized, like when they're heated up, electrons absorb some of that energy, but they don't hang on to it for long. They release the energy as a form of invisible light known as radiation. Those little dots orbiting the center are electrons. When atoms are energized, like when they're heated up, electrons are...
All right, did you do good on your formative questions, your questions that came in between your gizmos? You feel like you did good? We had one that we needed to clarify when it came to, what was the first gizmo we want? Oh, the atmosphere, right? You remember? All right, we need good ones. The questions that we already had on this one, we will continue on. We're checking and holding. All right, hold on to your notes. Make sure that you have your notebook, put your desk together. Okay. Thank you.
Thank you.
Thank you. Bye-bye. Awesome, awesome, awesome. I like that jacket. Bye. Bye-bye.